basic principles and just generate the whole lot of identities. So what I've got is beta minus alpha, and then I got the beta plus alpha. And this should be beta minus alpha then, right? So I just have this the wrong way about. Does that work then down here? Beta equals 0, alpha equals pi over 2. I get 0 minus 1 on this side. Here I get 2 times the sum of those is pi over 4, half the sum of those is pi over 4. That gives me this one. And then 0 minus pi over 2, that gives me sine of negative pi over 4, which is negative root 2 over 2. And then this is correct then, right? So there's a bunch of different ways of sort of arriving at what you need. I guess the check being not the greatest, huh? But yeah, so let's use that identity, okay? Which is hard to remember, right? Because there's different flavors, but it's not beyond the pale to reconstruct it. So so with that in mind, I can say the left side here I can replace with twice the cosine. The sum of these divided by 2 is going to be 4 theta, right? And the difference of those is going to be theta, or half the difference, right? So 5 theta minus 3 theta is 2 theta over 2 is theta. So I want this to be equal to cosine 4 theta. Well, these things I can divide both sides. Well, let's put it this way, because I want to be careful here. Cosine 4 theta. Cosine 4 theta could be 0, right?
Yeah.
So either cosine 4 theta is 0, in which case this equation is true, 0 equals 0, right? What if it's not 0? Well, I can divide by it, right? If it's not 0, I can divide both sides by that, whatever that is, non-zero quantity. So I'd get 2 sine theta is equal to 1, or sine theta equals 1/2. And so this one is equivalent, sine theta, right? So this one is equivalent to 4 theta is an odd multiple of pi over 2. That's where cosine is 0. And this one is equivalent to theta is either equal to pi over 6 plus 2 pi k, or 5 pi over 6 plus 2 pi k, right? The two places where sine is 1/2. And that tells me here that theta could be 2k plus 1 pi over 8. And here, these are the other values, right? So what if I want all the values between 0 and 2 pi? I start plugging in k's, right? So here theta could be equal to pi over 8, or 3 pi over 8, right? K is 0, k is 1, k is 2, I get 5 pi over 8, 7 pi over 8, you got more, right? 9 pi over 8, 11 pi over 8, 13 pi over 8, and 15 pi over 8, right? Those are the 8 multiples of pi over, well, they're not multiples, they're values for odd, those are the 8 odd multiples of pi over 8 between 0 and 2 pi. And what do we get for here? Well, k is 0, I got either pi over 6 or 5 pi over 6. If k is 1, well, then I got 7 pi over 6. And oh, no, that's bigger than 7 pi over 6. Yeah, so only k equals 0 works, right? Yeah. Otherwise, you're getting something bigger than 2 pi, obviously, right? So, where are we done? Yeah? How can we check this? I suppose we could use technology. Not a bad thing. per se, use technology, especially as a learning tool. I've seen weird stuff going on these days. You have somebody like a math problem, and they take a picture of it and send it some website where it tells them the answer, and they feel like they're doing math somehow. That's not going to work. Or you can go to Wolfram Alpha and enter in the problem there and look at the answer, and make sure you understand what you're looking at and how to construct it on your own if possible, or if you can't construct it on your own, why not? Right? What makes it difficult to do that? Would you ever use like GeoGebra or some tool like that?